Hello friends, so welcome to the 21st lecture and the first lecture of the 5th unit of this course. So in the past couple of lectures we have learned about multiple integral, especially double and triple integrals. So in this lecture I will talk about change of order in integration. Here integration means double or triple integral. So why we do the change of order in multiple integral? To understand this particular thing, let us take this simple example. So I am having a double integral which I have to integrate over a region R, and I am having here (6x square minus 40) dA, and my region R is given by a triangle with vertices 0, 3, 1, 1 and 5, 3. So I am having 0, 3, 1, 1 and 5, 3. So I need to find out this I need to evaluate this double integral over this triangle. So now if I sketch this particular region, so let us say these are my x and y axis. First point I am having 0 and 3, so 1, 2, 3. So this is the vertex is 0, 3. Then I am having 1, 1. So 1, 1 will be here, and finally I am having 5, 3. So 2, 3, 4, 5. So here. So I am having this triangle as my region of integration. So this is 0, 3, 1, 1 and 5, 3. So this is the region R. Now I need to integrate it, and here I can integrate this particular thing over this region in two ways. One is by taking a vertical strip, and another one is by taking a horizontal strip. So basically if I write the equations of these lines, then these equations are given by, so by these expressions. So this line is given by y equals to minus 2x plus 3. This line is given by y equals to half x plus half, and this line is given by y equals to 3. So now as I told you, if I take a vertical strip on this region, then so this line is y equals to minus 2x plus 3. This line is y equals to half x plus half, and this line is y equals to 3. So now if I take a vertical strip, then what I need to do? I need to divide this region into two sub-regions. One is R1, which starts from x equals to 0 and comes up to x equals to 1, because here in this region R1 my vertical strip will go like this. So the lower limit of y will be, so region is like this x y, such that the lower limit of y is minus 2x plus 3, and the upper limit is 3, while for x I am having limits as it start this vertical strip I will start from here and it will go up to here. So it will start from 0 and it will go up to 1. Once the vertical strip will be here, in the next point the lower limit of this particular strip will change, because here the lower limit will become this line. So let us define this region as R2, Now what I am having R2H xy, where the limits of y is half x plus half y, and it will go up to again 3, and the limits of x will be from 1 to 5, and the complete area or complete region will be R equals to R1 union R2. So, here for solving this particular integral using a vertical strip, what I need to do? I need to solve two double integrals, one for this region and another one for this region. So, integral will becomes 0 to 1 minus 2x plus 3 to 3, 6x square plus 40 dy dx plus x equals to 1 to 5, x plus 1 upon half to 3, 6x square plus 40 dy dx, and this will be the complete value of this integral. This is one of the way of solving this problem. The other way of solving this problem is to take a horizontal strip to cover the whole region R. So, if I take a horizontal strip to cover this region, so this step will start from here and it will cover this region like this. So, here the region will become xy, where the lower limit of x will be, so this line, so this line is y plus 2x equals to 3. So, x will become 1 by 2, 3 minus y, and the upper limit will become this one. So, this will become x equals to 2y minus 1, and my y will go from y equals to 1 to y equals to 3. So, here the limits of this double integral will become 3 minus y upon 2 to 2y minus 1, and y will be 1 to 3, 6x square minus 40 dx dy. So, what I am doing? I am taking two different ways of solving this particular problem. In one, first I am integrating with respect to y and then with respect to x, means I am taking the variable limits for y and constant limit for x. In this particular thing, in the second way, I am taking just opposite. I am taking variable limits for x and the constant limit for y. So, I am integrating it first with respect to x and then I am doing it with respect to y. In the earlier case, I need to evaluate two double integral, but in this case I need to evaluate only one double integral, and which is quite simple when compared to earlier case. So, hence order matters in evaluation of multiple integral, as we have seen in this particular example. So, in one way it becomes easy to calculate, in other way, in other order it may become difficult. So, this is one of the reason for taking or for changing the order of integration. Now, take one more example. And this is example again from the double integral. So, here x equals to 0 to 3 and I am having y equals to x square to 9. In this particular problem or example, my function which I need to integrate is x cube into e raised to power y cube and then dy dx. So, what I am having? I need to evaluate this particular integral. So, according to given order, what I need to do? First I need to calculate this particular thing, means I have to integrate it with respect to y. However, I cannot do it. Why? Because if I have to integrate it with respect to y, I need a term of y square here due to the cube of y in the exponential term. So, that I do not have, and hence I cannot evaluate this integral in this order. So, what is the solution? Solution is to change the order of integration, and then we will see whether we can solve it or not. But for this, as I told you, change of order means changing the direction of strip. If you are covering your region of integration by horizontal strip, changing the order means take the vertical strip and vice versa. So, let us take sketch the region of this particular example. So, what I am having here? Y equals to x square. So, y equals to x square will be like this, and it is going up to y equals to 9. So, let us say 3, 6, 9. So, this particular thing. So, this is the point 3, 9. And x is going from 0 to 3. So, my region is this particular area bounded by these 3 lines. Now, what I am doing? According to the given problem, I am taking a vertical strip which is having lower limit as y equals to x square and going up to y equals to 9, and starting from x equals to 0 to 3. Now, what you do? Change the order of integration. So, instead of this vertical strip, let us take this horizontal strip. So, now this is equals to the lower limit of x will be 0, upper limit will become this curve, and what is this curve? Y equals to x square. So, this I can write x equals to root y, because now I need to take the variable limit in y. So, 0 to root y, and then what I am having? This strip will start from here, it will cover this region like this. So, it will go from 0 to 9, x cube e raised to power y cube, and then now dy dx will become dx dy. Now, integrate this, the integral in square bracket, this will become 0 to 9. So, it will become e raised to y cube, which is as such, and x cube will become x4 upon 4. Limit will be 0 to root y and then dy. This thing equals to 0 to 9, 1 by 4. When I will put root y, it will become this term as such. So, when I will put root y, x raised to power 4 will become y square, and then when I will put 0, it will become 0. So, into dy. Okay, so now we are having this integral. Now what I will do? I will take y cube as t. So 3y square will become dt, dy equals to dt, and y square dy will become 1 by 3 dt. So after substituting here, it will be 1 by 4, it will become e raised to power t upon 3. So I will take 1 by 3 out dt. The only thing I need to change limits when y is 0, t is 0. So no change in lower limit. However, when y is 9, t will become 9 raised to power 3. So this will become 1 upon 12. The integral of e raised to power t will be e raised to power t. So e raised to power 9 raised to power 3 minus 1. This is the final answer of this particular problem. So here you have seen the original problem was not solvable in the original order, but once you change the order we can solve this particular problem. Hence, we are having the necessity of change of order in many double integral or triple integral problems. Okay, so basically change of order means to changing the order of integration, and why we need it, that we have seen in these two examples, where sometimes changing the order problem becomes easy and sometimes it is not solvable in the given order, but after changing the order you can integrate it. So, and the idea behind the change of order is just change the direction of the strip covering the region of the integration. For example, if you are having vertical strip, make it horizontal, and if you are having horizontal strip, make it vertical. So basically if it is dx dy, make it dy dx and vice versa. So let us take one more example of the same type where we need change of the order. So my example is double integral, it is coming as the limit y raised to power 1 by 3 to 2 and x is 0 to 8, and the function f of x y is x raised to power 4 plus 1 square root and then dx dy. So find the value of this double integral. Now in the original form what I need to do, first I need to evaluate the definite integral in the square bracket. However, for doing it, what I need, when I am going to integrate this particular thing, I need a term x raised to power 3 out of this, because then only I can assume that x raised to power 4 plus 1 equals to t. I can make some substitution, I can eliminate this thing, I can integrate this thing, but that I am not having here. So I cannot integrate it as such, means I cannot integrate this with respect to x. So the solution is change of order. So changing the order means, let us do it first with respect to y, and if you are doing it first with respect to y, then you need constant limit for x. So what I need to do, I need to change the direction of the strip. So for that first I need to sketch the region, and region will be this is the or y equals to x cube. The other one is it will go up to start from here and it will go up to 2. So, let us say this is the point 2 8. So, region is this one, and at this moment what I am having? I am having this particular strip. Now, change the direction of this. So, let me take this kind of strip, that is the vertical strip in this problem. So, it will become the lower limit of this vertical strip, that is y equals to 0, upper limit will become x cube, and then it will start from here 0, it will go up to 2. Now, when I am integrating it 0 to 2, so this is as such into y 0 to x cube dx. Once I put the limit, so this will become x cube square root x raised to power 4 plus 1 dx, and now you can evaluate it easily. So, this is the another example where we cannot solve the original problem in the given order, but after changing the order we can solve it very easily. So far we have talked about change of order in Cartesian coordinate. We did not touch polar coordinates. So, now let us take some example in polar coordinates where we need change of order. So, before that let me explain how the double integral, or we cover the region of the integration in polar coordinates. So, in polar coordinates what we are having? Theta equals to 0, theta equals to pi by 2, and then we are having some point r theta here. So, r theta means this distance is r and this angle is theta. So, this is the meaning of polar coordinates. So, if this point is x y in Cartesian coordinate, then x will be r cos theta and y will be r sin theta. That is the projection of this on x axis and y axis. Now, let me have this region in some problem over which I need to integrate. So, in polar I am having these two, then some integrate, that is f of r theta and dr d theta. So, r equals to some g1 theta to g2 theta, and theta is some theta 0 to theta 1. So, theta 0 and theta 1 are constant limits, while for r I am having functions of theta. So, in this way how it will work? I will take a radial strip like this and it will cover this region like this. So, means the lower value of r, the upper value, because this curve will be some curve of r equals to some function of theta, and it will start in this example, let us say theta equals to 0 to pi by 2. So, theta 0 will be 0, theta 1 will be pi by 2. So, this is the way when you are using the order first dr and then d theta. If you are taking the order in another way, means you are having variable limits for theta, those are functions of r, and then some r 0 to r 1 means constant limit for r. So, in this order f r theta will become means dr d theta will become d theta dr, means first you have to integrate with respect to theta and then with respect to r. So, in this particular thing, how we will cover our region. So, in this case region will be covered using this circular arc. Like this. So, here I will be having some this value of theta and this value of theta, and then constant limit for r means it will start from here and it will go like this up to here. So, r 0 r 1 like this, it will cover the whole region. So, changing the order means if you are taking this kind of strip, that is the radial one, make it circular, or if you are having circular means you are having this order d theta dr, make it radial. So, this is the idea of change of order of integration in polar coordinates. Now, let us take one or two example of this case. So, my first example is change the order of integration in the integral theta is 0 to pi by 2 and r is 0 to 2a cos theta f r theta dr d theta. So, here these are the limits for r 0 to 2a cos theta, and for theta I am having the constant limit, that is from 0 to pi by 2, means in first quadrant. So, let us sketch this region first. So, r equals to 0 means here, and the another curve is r equals to 2a cos theta. R equals to 2a cos theta means r square is 2a into r cos theta. As you know, r square is x square plus y square equals to 2x. So, it means r equals to 2a cos theta is nothing but this circle having center at a and 0 and having radius a. So, in first quadrant this will be this circle. So, it will be center will be at a 0 and radius is a. So, this point will be 2a 0. So, r is a, theta is 0, r is 2a, theta is 0. Theta is going 0 to pi by 2. So, we are taking only in first quadrant, and according to the given problem we are taking the radial strip. Why radial strip? Because my strip is starting from this point, that is r equals to 0 and finishing at this curve which is r equals to 2a cos theta. So, 0 to 2a cos theta, and this is radial strip will start from here and it will go up to here, that is the theta equals to pi by 2. So, now cover this region by circular arc. So, circular arc will go like this. So, from it is starting from theta equals to 0 line. So, theta equals to 0. Where it is finishing? It is finishing on this curve. So, what is this curve? This curve is theta equals to cos inverse r upon 2a. So, upper limit of theta will become cos inverse r upon 2a, and now the strip will start from here. So, here r is 0 and then it will go like this up to here, that is 2a. So, 0 to 2a f r theta d theta dr. So, this is the change of order in polar coordinates for this particular example. Take one more example to make a very clear understanding of this particular concept. Change the order of integral theta equals to 0 to pi by 3 and r is a sec square theta by 2 to at a upon 3 cos theta f r theta dr d theta. So, we need to solve or we need to change the order of this particular integration. Here limits are looking a bit complicated if compared to the earlier example. So, let us see. So, like earlier case, the upper limit is r equals to 8a by 3 cos theta. So, it is clearly a semicircle in first quadrant having center at 4a by 3 0 and having radius 4a by 3. So, it is the circle at a by 3 0. Now, the other curve is r equals to a sec square theta by 2. So, when theta is 0, r is this term is 1 because sec 0 is, so sec 0 is 1. So, r equals to a. So, this curve will start from r equals to a. And then it will intersect this curve at pi by 3. So, it will go like this and then we do not care after this because this is, so as I told you it will intersect at pi by 3. So, this line is theta equals to pi by 3. So, my region of integration is theta equals to 0 to pi by 3 and this curve region between this curve and this curve. So, this is the region of integration. I am taking the radial strip according to the original problem. So, this radial strip is going like this, means the lower limit is this one, a sec square theta by 2, upper limit is 8a by 3 cos theta, and starting from theta equals to 0 going up to theta equals to pi by 3. Now, take the circular strip. So, my region starts here. So, this is a circular strip will be like this. When it is 4a by 3, this is 4a by 3 because the radius of this. So, mean circular strip will start from this line, that is the theta equals to 0 and ending on this curve. So, what is this curve? R equals to a sec square theta by 2. So, from here I can write sec square theta by 2 is r upon a. So, sec theta by 2 is square root r upon a. So, theta will be 2 sec inverse square root r upon a. So, 0 and it is finishing 2 sec inverse square root r upon a, and r is starting from r equals to a and going up to 4a by 3. F r theta d theta dr. But please look, so far we have covered only this much region, this region is left, because why? Because after that theta will start from 0 but ending up on this curve instead of this curve. So for this I have to take one more region. So plus theta equals to 0 ending on this curve. So this curve is r equals to 8a by 3 cos theta. So theta will be cos inverse 3r upon 8a. And then r will go from 4a by 3 to 8a by 3, f r theta d theta dr. So this is the complete solution after changing the order of the integral. So now my region is divided into two sub-regions and I need to calculate the double integral separately on each sub-region. So this is the change of order in polar coordinates. So in this lecture we talk about change of order and we have taken some examples from Cartesian coordinates and then from the polar coordinates. We also discuss why we need change of order in multiple integrals. So thank you very much.